We're going to review a little bit on stable electron configurations, and then we're going to get into some ionic bonds and some electron dot diagrams. Now, some of this is review and some of it's not, so please pay attention as we go along. There's going to be a worksheet that's going to test you on some of this stuff later, and then you'll also have a quiz on it. Remember, you can pause, rewind, and watch a video again over if you need help with any of this. These notes are also online on my website, so you can get them there. So, stable electron configurations. Remember, the most stable atoms are the noble gases, and the noble gases are over on the right side of the periodic table in column 8A. They're stable because they have 8 valence electrons. Remember, valence electrons are the electrons in the outer energy level. And when something gets to 8 valence electrons, it's stable. There is one exception to this. It's helium. Helium is up in the first row. It's only got 1 energy level. It only has 2 valence electrons, but it fills the first energy level. So helium is a stable atom. So you have to keep that in mind. There is one exception to the rule of 8, and it's helium. Now, if an atom doesn't have a stable configuration, it will form a bond to reach a stable configuration. And we'll talk more about bonding in a minute, but for now I want to be able to recognize stable configurations versus unstable configurations, and there's a way to do that. We use a picture called an electron dot diagram. Okay? So valence electrons are really important when we're determining whether or not something's going to react, and so we're going to draw an electron dot diagram that shows only the valence electrons. So, electron dot diagrams are pretty easy, but you will need a periodic table and you will need to know your element symbols. So all this information can be gotten from the periodic table. And you need to remember the A group, the group on the top of the column, gives me how many valence electrons are in there. So if I grab a periodic table and we take a look at it, you guys remember that up in the top we have the row numbers. Group 1A is the alkali metals with hydrogen. They all have 1 outer electron, 1 valence electron. 2A has 2 valence electrons. The B group elements in the middle, they don't count. And then we have the group 3A, 4A, 5A, 6A, 7A, 8A. And right, these are the noble gases. They have 8 valence electrons. Alright, so the A group number gives us the number of valence electrons, and we can use that information to draw these electron dot diagrams. Now there's a couple rules we have to know. First, if you take an element symbol, and so let's say I take the symbol for oxygen, which is O. We want to imagine that each side of that O is actually contained in a box. Okay, so it's got a 4-sided square around it, just like that. And each side of this can have up to 2 electrons on it, but no side of it gets to have 2 electrons until each side has at least 1 electron. Okay, so if I look at oxygen, if I grab the periodic table, I can see that oxygen is a group 6A element. I know I'm going to put 1 dot, 2 dots, 3 dots, 4 dots, 1 on each side, and then 5, 6. So I have drawn this oxygen atom with only its valence electrons around it. Okay? And remember, I didn't put 2 on any side until each side had 1. So I followed my rules. Now, as always, there's got to be an exception to the rule, right? And that's helium. And remember, helium is that first element up in the, or the second element up in the top row, and it actually does fill its outer energy level. So to make sure that we know helium has a full energy level and it's a noble gas and it's not going to change, we put its 2 electrons on one side. So helium's electron dot diagram looks like that. And that tells us it's got a full energy level. Right? So let's actually do a little bit of practice. Some example dot diagrams. Okay, periodic table, and you can check yourself with the K12 periodic table on the iPad, but I actually want you to know how to do these. Remember, you probably won't get that app on a test. So we need a periodic table, but then it's pretty easy. So I'm gonna pick 4 elements from the A groups. I'm gonna pick lithium. I'm gonna draw its electron dot diagram. I'm going to pick nitrogen. I want to see its electron dot diagram. I'm going to pick silicon. I want to see its electron dot diagram. And then finally we'll pick krypton, and we'll see what its electron dot diagram looks like. So first one I want to find is lithium. So let me grab my periodic table. Alright, so my periodic table is here, and lithium is right here in the top left. It's a group 1A element, so that's all I need to know. Oh, and its symbol is Li. So with that, I can get its electron dot diagram. So lithium, Li, has 1 valence electron, and it doesn't matter to me which side you put it on. Okay, I'm going to put it over here. It's just as valid to put it over here, or at the top, or at the bottom. it doesn't matter. But do remember that that first L is capital and the second I is a lowercase letter. Okay, and then we have to go find nitrogen on the periodic. All right. So here's nitrogen right here. It's a group 5A element and its symbol is N. So we can go ahead and put it. We can draw its electron dot diagram. So nitrogen, N, and it was group 5A atoms, so it gets 1, 2, 3, 4, 5. And again, it doesn't matter which side gets those 2. So you could draw 2 here, 1, 2, 3. You could draw 2 at the top, 1, 2, 3, or you could draw 2 at the bottom, 1, 2, 3. Okay, as long as every side has 1 before that last side gets 2. And let me grab the periodic table one more time. Silicon is right here. It's a group 4A element. Si is its symbol, so I'm going to draw its electron dot diagram. Silicon, Si, and 1, 2, 3, 4. And there are no other ways to draw that one because I have 1 electron per side. And finally, I have krypton. Now remember, krypton is actually a noble gas. It's a group 8A element. So let me pull up the periodic table and show you that. All right. Krypton is right here. Its symbol is Kr, and it is a group 8A element, so it has 8 valence electrons. So krypton is right here, Kr, 1, 2, 3, 4, 5, 6, 7, 8. Now I know I broke the rule and I put 2 on each side before any side had 1, but that's because I knew it had 8, right? If I filled it in 1, 2, 3, 4, 5, 6, 7, 8, then I'm okay. So those are our simple basic electron dot diagrams, and if we can do that, then we can understand a lot of what's going to happen when atoms form bonds. So let's take a look at that. Okay? Ionic bonds. Now a bond forms when atoms want to get stable, and there's 2 ways they can do that. They can transfer electrons or they can share electrons. And ionic bonds occur when they actually transfer electrons. Okay? So when an electron is transferred, one atom gains an electron and another loses an electron. So we're only talking about the ionic part, which means we're only talking about the transfer of electrons. Now, if you think about what that means that when an atom gains or loses an electron, it went from neutral with equal number of pluses and minuses to actually having a charge, because now our number of minuses is changed. Okay? And since it's a charged atom, we don't call it an atom anymore. We call it an ion. Ions are atoms with a charge. Okay? Now, there's 2 things that can happen. If an atom loses an electron, what does that mean? Well, it means it started neutral with an equal number of pluses and minuses, but it just lost a minus, which leaves it a little bit positive. It means the atom actually has an overall positive charge. Okay? So this is called a cation. Okay, it's not a cation, it's a cation, and it has a positive charge. A cation is a positively charged ion. Now, metals form cations. The periodic table shows us that the metals are in group 1A, 2A, and 3A. There's a few over here, but 1A, 2A, and 3A primarily. Well, these are going to have 1 outer electron, 2 outer electrons, and 3 outer electrons. The easiest way for this thing to get down to a full energy level is actually for it to lose those. So metals form cations, they lose their outer electrons and gain a positive charge. Okay? So when we're drawing an electron dot diagram for a cation, it looks a little bit different than when we draw the electron dot diagram for just the atom. So let's start with that lithium atom that I had. Okay? Lithium's electron dot diagram looks like that. Well, this is unstable because it's got 1 electron out here. If lithium could actually lose that electron, then it would drop down to a full outer level. We don't draw it like that. We just say, well, lithium lost its electron and now it's a plus charge. Okay? So this is actually the electron dot diagram for a lithium ion. Okay? Lithium ion. Now let's do another metal real quick, maybe one that has 2. So if I find calcium, calcium has symbol Ca. It has 2 electrons. Okay? Remember, 1 per side. Well, it'll give those both away. But if it gives away 2 electrons, it's not just a 1 plus charge, it's a 2 plus charge. Okay? So because there's no number here, we understand it to be 1. Calcium is a 2 plus ion. Aluminum, okay, is over in group 3A. It has 3 outer electrons, 3 valence electrons. It will lose all 3 of those electrons. that means it's 3 electrons short. It means it's got 3 extra protons, so its electron dot diagram is a 3+. So metal cations are easy. You just get rid of all those electrons until there's none left, because that way it doesn't have any to lose. It's stable, and you count out how many it lost, and that's how positive it is. Now, nonmetals actually will do the other thing. Nonmetals gain electrons. They're on the other side of the table. They're closer to having 8 electrons than they are to having, well, gaining 1 or 2 gets them to 8, then losing gets them to 8. So it's easy for them to gain. Now, if an atom gains electrons, that means, well, we started with equal amounts of plus and minus, and now I just added in more minus. The overall charge is going to end up negative. Okay? So we're going to have a negatively charged atom. And a negatively charged atom is called an anion. It's an atom with too many electrons. Nonmetals over on the right side of the table, they form anions. Okay? If we draw these, it's a little bit different. So let's say I pick a nonmetal on my periodic table. Okay? And we're going to basically stay in the last 3 columns over here. So a nonmetal may be nitrogen or phosphorus. Let's go with phosphorus. Phosphorus is symbol P. It's a group 5A element, so it's got 5 outer electrons. And so here's phosphorus, P, with 1, 2, 3, 4, 5 outer electrons. If I look at that, it's got an open spot here, an open spot here, and an open spot here. So it'll pull in 3 electrons. So its electron dot diagram of its ion, let me start that over, is the P, but now it'll be full 1, 2, 3, 4, 5, 6, 7, 8, because it fills in those 3 open spots. But now that it's filled those in, it's got 3 extra electrons. That's 3 extra minuses, so it has a charge of 3 minus. The halogens, they don't have to work so hard. That's what makes those so reactive. Fluorine starts with 7 valence electrons. It's a group 7A element. Okay? Which means it has 1 open spot, and for it to get to 8, it only has to take 1. It's really easy for it to do that. Fluorine will actually form this ion, 8 valence electrons, and it's got 1 extra in it, so it's a 1 minus ion. And you can just write that as F 5, 6, 7, 8 minus. Okay? So drawing the anions and drawing the cations, you've got to decide if we're gaining electrons or we're losing electrons. And once you have that, then it's just a matter of filling in or losing those electrons and counting up the charge. Okay? So drawing electron dot diagrams is a pretty essential skill, but being able to convert those over into ions is actually how you're going to be able to come up with the bonds. And that's what we'll take a look at in our next video.